Okay, so let's begin. Welcome all. Welcome to the sixth lecture of this workshop, which is on Introduction to MATLAB. Uh, Previously, what we have seen was the basics of MATLAB, the basic programming in MATLAB, how various decision loops works in MATLAB, right? So decision statement as well as the loop statement, how to implement, and we saw some example. And from the last lecture onwards, we started with solving some chemical engineering problems, where we first learned about the solution to linear algebraic equation, and after learning that, we tried to solve the distillation problem with the learned method. So if you recall the last lecture, right? What we did in last lecture was we first learned how, if we have simultaneous algebraic equations, right? In that case, how to find the solution of that equations, right? So for that we rely on the matrix algebra, and we use Gauss elimination method, Gauss Jacobi method, etc. We coded Gauss elimination with our own scripting, and when we compared with the inbuilt MATLAB commands that are available to us to solve that same problems, right? And once we learn that, then we move forward with the multi-component distillation column example and solve the same problem, which relies on this numerical method, where we have to find a solution to linear algebraic equations, right? Now, with that idea in mind, so in today's lecture, we will first learn about how we can find the solution to non-linear algebraic equations. And once we learn that, how to find solution to this non-linear algebraic equations, we will solve the problems, specifically chemical engineering problems, which involves non-linear algebraic equations in its model. Right? So maybe in today's class, the way I have planned the content, we might go slowly, and we just first learn about the solution to these equations only, non-linear algebraic equations. And maybe in next class we will solve some specific chemical engineering problems, right? Now, so when we talk about non-linear algebraic equations or non-linear equations, right? So what categorize this non-linear equations? So in non-linear equation, obviously, as the name suggests, you have some non-linear dependencies. That means you will have some sort of a power in your equation or in your model. So that becomes a non-linear, right? But to which also there are further types. You have algebraic equations and you have uh, trans transcendental equations, right? So in algebraic equations, is the equation that is expressed in terms of the finite combination of algebraic operation by addition, subtraction, or multiplication, right? So basically considered your quadratic equation. So that is an algebraic equation, but it's a nonlinear type. While transcendental equations, they involve the complex numbers as well as some mathematical functions in its part. Right? So like consider this example where you have 2 to the power x equal to x square. Right? So here this part is it involves the power x to your number, as well as x equal to e to the power minus x, or some cosine or trigonometric terms that you will use. Then in that case your non-linearity becomes complex, right? Because here the behavior of system will depend upon whatever functions you have. So in case it will depend upon the cosine, in this case it will depend upon the exponent behavior, etc. Right? And when you have what's the difference between the algebraic equation and transcendental equations? So in algebraic equations, since they are algebraic and represented in terms of one variable with a finite combinations, right? So you will have some specific solution, okay? While in transcendental equations, what you have is you could get finite or infinite root depending upon what kind of equations you have, right? So if you think about it, cos zero value, right? So cos zero, you are getting at theta is equal to 90 degrees centigrade. Then if you move ahead and go theta is equal to 270 degrees centigrade, also you get it. At every interval of plus 180 degrees centigrade, you will get the cos theta value as 0, right? So that becomes infinite. So for that cos theta to become equal to 0, you will have infinite possible roots. Now in that we look for specific range, and then we decide what could be the R root, right? So This is what transcendental equations look like, and whatever functions which are made of such equations are called as transcendental function, right? And the one more thing is that when you have such functions, you cannot find that solution analytically. Okay, so basically you have to rely on some sort of a numerical method to find its solution. So what are these numerical methods available? So solution to such nonlinear equations is done by this basic numerical methods which I have listed, is a bisection method, Gödel section method, secant method, or Newton-Raphson method. While there are some built-in MATLAB solvers also present, which are F0, Fsolve, VPA solve, and roots command. Okay, so we will see this command after first each, and we will also learn about some of this basic method. Obviously, there are other methods also which are more thorough in solving this nonlinear equations. I'm just listing the basic method which you might have encountered in your previous syllabus, or you might be going to encounter in your current syllabus, right? So, first let's look at what are the built-in MATLAB solvers that you have and what kind of fundamentals they work on. So first you have F0. So F0 is used to find a root of scalar nonlinear equation for a single variable, right? So here F0 finds a root for your scalar nonlinear equation which has a single variable. You might require some initial guess or an interval where function changes sign, and it uses the combination of bisection, secant, and inverse quadratic interpolation. Don't worry about this method. We will just touch upon some aspect of bisection and the Newton-Raphson method. Then you will understand. Okay? So let's look at the example of F0 command in MATLAB first. So first, whenever you are encountering any new command or any new function in MATLAB, what I would like to do is to understand its manual through help function. So I will write help F0 and see its manual, how MATLAB recommends its use. So here it says F0 is a single variable nonlinear zero finding, where you write the F0 function as F0, you provide some function value and X0 value. Okay, so here it tries to find the zero of the function fun near the x0, where x0 is a scalar quantity. Okay, now obviously we will not go through the entire description, but let's look at some examples that might be given here, right? So here they have given the example of finding the root of sine x or sine theta, right? So you are defining f0. Here function is written at the rate sine, and the initial guess is provided at 3. So it will provide the value where sine x becomes 0, which is close by to the 3 part. Okay. Same way you have other examples also. You can also provide your own function. So here they have created my function, which is cost cx, where c value is provided, and then you find the solution of to this function. Okay, now here one thing you will notice that we have to provide the function uh, in this f0 command, right? So to provide in function in MATLAB, we have few options pre-built available, right? So I can provide, no, let me write a script so that I can save it and you guys can see it later. Providing functions in MATLAB. Your own functions slash equations in MATLAB. So let's say your first option is inline command. Okay. So when I write any function f is equal to inline, and you have to write a functional form. Let's say I write x square minus 4. Okay. That's a parabola equation, right? So this is my inline function, and when I run it, let me store it, various ways to define a function. And if I run it, can you see it shows inline function fx equal to x square minus 4. Now I can call this function f and find its value for any x part, right? So let's say I find function value at x equal to 1, at x equal to 2. Okay, so if I write it and run this command, I will see this. So fx1 will be 1 square minus 4, so minus 3. 2 square minus 2, so f2 is 0, right? So this is one way. Another way is using @ part. So here your f becomes, so if first you write @ and then you provide what will be your dependent variable. Okay, so in case my dependent variable, I'm writing the same x square, and then I have to write the equation which is x square minus 4. Okay, and if I run it, again I am getting the functional handler. So first one is the inline function and this is the functional handler. So it's a second way of providing it, where you provide the value of variable x and this is the function, right? So same thing, I can call it f of 1 here, f of 2 here, and run it, and I should get the same answer. Okay? Then third option that you have is using symbols. So I define syms sims. So sims defines a symbol. So I defined a symbol x in my system, and I write my function f is equal to x to the power 2 minus 4. So here I have already defined my variable x as a symbol, right? So that's why I'm writing sims x. So f is x square minus 4, and if I run it, here again you will see what, yeah. So this is how function is defined. But now when you are using the symbols to define a function, in order to find in some values, okay, you have to use the substitute command. So this is subs. So it will show, you can see its description, it says symbolic substitution. So let's say when you have symbolic function f and to which you want to substitute the value. So I'm substituting the value of x as 1 subs f as 2, right? Then I will get the answer. If I write now f is equal to 2 directly, I will get an error that, but when I write sub f equal to 2, I will get the answers. Why? Because the function is defined symbolically. So symbolically function is defined this way. I'm getting the answer by substitution, but when I write f is equal to 2, I'm getting an error, right? So these are the ways why this symbol part is used. This helps to even find out differential of any function, simple functions, right? So there is this diff command where you provide a symbol equation, right? So if I write diff f, I should get the differential of function f. And can you see this is function x square minus 4 and it's a differential. Diff f is 2x, right? So that's why the symbol function is also used, because it helps you to show your functions in forms of symbols, and then you can substitute the values of variables, right? So these are the three common ways. Now understand this, when you are writing use @ this part, this is kind of similar to writing your function which we had learned initially, right? That we create a function file. So this kind of becomes similar to creating your function file, but in a shorter format, and that too in your script. So it becomes handy when you want to define some function in your script, but you don't want a separate specific file to define that function. So you can use this part. Okay. Way. You can also have multivariable functions defined. So I can have multi-variable functions. So let's look at the case of the inline function example. F is equal to inline. I can have x1 square plus x2 square minus 4 as in my function. So I'll write it in brackets. Okay. And when I want to call the value, so since I have two variable x1 and x2, let's say I write f0 comma 2 and run the part. Okay, so I am providing value of two variable x1 and x2. How do I understand whether the function has created two variables or not? So if you will see, when you run such inline function, you find that inline function has a two variable x1 and x2, right? So when you are calling this function, you have to provide two guess value or two values of the independent variable to find the value of function at that particular point, right? So with this understanding of how to define the function through various routes, now let's look at the solver part, right? So first solver was f0, so to find the root of a non-linear equation with a single variable, right? So here, let me look at the solver command, not f0 command. F0. Just give me a minute, please. Yeah. So see here, what I'm doing, I'm defining the first function f is equal to variable at the rate variable x square minus 4, and then I'm using f0 command where I have to first provide the function and some initial guess, right? So here we know that for this function to become equal to 0, my root will be x equal to 2, right? So when you run this part only, okay, let me copy paste this and run it here. This is how I get it. So my function is defined, xsolve solves the function, okay, I can just call this way, and you can see I got the solution, okay. Same way, if I have another function again, but it's this function has is only single variable function, right? So it has only one variable, that then only f0 can work, right? So I'm using this function which is exponential to the power x minus x minus x, right? So this example we saw, it's that one, e to the power minus x to minus x, and I'm providing the initial guess 0 and trying to run the solution, okay. So this is what my solution will look like. Now one more thing, your initial guess helps to decide the solution, right? So here for the second part, my initial guess was x0 equal to 0, and I got the close by value of 0.576. Now let's say I don't know the value and I write x0 equal to 11 and try to run it and see whether I get the solution or not. Yeah, I'm still getting the solution because the method that they are using could be, it's a combination method, right? So uh, yeah, so it's using the combination of bisection secant and inverse quadratic, so that's why it's going to the solution much faster. But there are some numerical methods for which the initial guess becomes very important to find a solution, right? We will see that example also once we come to that part. Then second function that you have in MATLAB is fsolve command. In fsolve command, it solves the system of non-linear equation but with multi-variables. You have to provide some initial guess, and it uses the trust region reflective or Levenberg-Marquardt algorithm, right? Don't worry about this algorithm, but if you are learning about optimization, or in future if you might see or do some optimization problems or try to follow this optimization methodology, you will understand these are the fairly common methods which are used to find the solution to optimization problems, specifically for multivariable components, right? So to find the solution of multivariable functions, we use fsolve part, right? And this is its help part. So fsolve, again, it attempts to solve the equation where it tries to equate your function to 0 and find the value of your variable which provides the fx is equal to 0. You provide the syntax in this manner where you write fsolve function and the initial guess. Okay, there are further options also available. For that, I will recommend you to go to description. So these are basically related to what kind of conversion you want to have, etc. Okay, so here you can see the example. First, we are defining some function, right? Which is my function, and then they are putting the initial guess. Again, this part is related to the solution and whether it converges or not, but we have to just focus on this part for our consideration, right? So I provide the function value. Function is defined at here, right, through MATLAB, the function command part, and then it solves the solution. Okay, right. So let's look at the f solver example. So here I have two equations with two variables. So first I have x1 square plus x2 square minus 1. This is my equation 1, and my equation is second equation is x1 minus x2. Okay? So here the function is defined as at the rate variable x, okay? And then that to this variable x, I am saying the first component of variable will be x1, okay, and the second component of this variable is x2. So essentially this becomes that x will be my vector, okay, it will be my vector part, right? So here I have two equation which I want to solve, right? So you can consider this as this is a equation of circle, this is equation of line, and you want to find the intersection of them where this both become like where your x1 and x2 satisfies both equation, right? So in that case your equation 1 and 2 will look like this. I provide the initial guess, okay, and use the fsolve command to find its solution. Okay, so if I run it, can you see it has solved, equation is solved, it puts that command, okay, and then it provides that fsolve completed because the vector of function values is near 0 as measured by the value function tolerance, and then stopping criteria are given. So this is your solution, okay? So 0.701, 0.7071, okay? So this is basically 1 upon under root 2 values are this one. And if you will put it here, it will satisfy both the equations, okay? Then again you will have second example where you have two equations. I think it's same equation, solve using fsolve. I don't know why I have this two times, but I think I might be, I might have made some mistake. They are essentially both same equation, so there is no need of this part. Sorry. Yeah, so there is no need of this part. So this is how fsolve works. Then you have VPA solve and solve command. Now VPA solve, it finds the numerical solution to symbolic equation, both single and multivariate. You don't require any initial guess. It works with the symbolic variable and can find all the solution in the specific range, right? So this is VPA solve. So what it finds is, let's say when you have a symbolic equation and you want to find its solution, then you have to use this VPA solver, right? So here, first I'm defining a function through the symbol x, right? So first I'm defining symbol x, then my equation is x cubed plus 2x minus 5 is equal to 0. So this is my equation, and I'm using my solver, calling VPA solve, providing the function, and variable value function and my symbol value, and it will provide me the solution. So first let's look at the syntax. Help VPA solver, sorry, not solver, VPS solver. Yeah. So this is how it works, that you provide an equation. You don't have to provide the symbol value all the time. Right now I have just provided it. If you want, you can provide the initial guess also, but that all things are secondary, right? So here you can see they have given the multiple examples of how this works. So let's say I have this part and I want to solve it. If I just run it, you can see VPS solve. It has solved this problem, cubical problem, x cube plus 2x minus 5 is equal to 0. I will get the three roots. And what are these three roots? So first root is real and the second two roots are imaginary. Okay. So it's providing me that. For the second case, I have x cube minus 6x square plus 11x minus 6 equal to 0. So symbolic equation is given and I want to find its solution. So here the solution is numeric. Okay. The equation is provided in form of the symbol while solution is the numerical part. So you can use the VPA solve. Then you have solve command which finds the exact symbolic solution of the equation. Okay. So it is similar to VPA solve, but rather than getting the solution in form of the numerical values, you will get it in form of the equations. So I have same sort of equations here, right? So if you have this x cube plus 2x minus 5 is equal to 0, here focus on this part that I have defined the equation, same equation, and I am using the solver. So see, it's providing me the solution, but in form of the symbols. So I will get the three roots since it's a cubical equation, right? And this root, it will look like this, that z cube plus 2 times z minus 5, where z is your variable, and then you will have value of 1, 2, and 3 that you can substitute here. Okay. So these are root 1, root 2, and root 3. Same way, you can run this part also, that sin x equal to 0, right? So that will be possible at for all value of 0. So sin solver, here you are getting the solution as 0. For the second part, sin x plus cos x equal to 0. So your solution will come at minus pi by 4, right? So where you will see that both one is positive, one is negative, and that's why the summation will become 0. Okay. So this is how you can use it, but this time this provides the solution in form of the symbols. Okay. Then you have this command also, roots, which is used to solve the uh, which is used to find the solution of the polynomials. So if I write help roots, this is how I get root c computes the roots of polynomial whose coefficients are the element of vector c, right? So let's say you have any polynomial which is given as c1 x to the power n plus c2 x to the power n minus 1 up to cn into x plus cn plus 1. Okay, let me show you the documentation part. Right? So let's say you have this sort of a polynomial equation, right? So in order to find its solution, you have to count the coefficients. So it's a quadratic equation, right? So it will have three coefficients: x square coefficient, coefficient of x, and the constant part, right? So I'm solving it by providing the all three coefficients in my roots command. Okay, so you create a vector of this coefficient, put it in roots, and find the solution. Same way, let's say you have x to the power 4 minus 1, right? So here I have x to the power 4 coefficient, rest of the all coefficients are 0 for x to the power 3 to up to the x to the power 1. So I will create a vector which contains this information. Okay. So since it's x to the power 4, I will have 5 coefficients. Coefficient 1 is power 4, coefficient 2 is of power 3, coefficient 2 is of power 2, coefficient 3 is of power 1, and the last coefficient will be the constant part, and you get the solution, right? So this is how you can use the roots command in MATLAB, right? Now, before going ahead, let's learn some basic fundamentals on which this algorithm works, right? So, first of the very common method to find the solution to any single variable optimization problem is the bisection method, or it's referred as interval halving method also, right? So let's say you have a function fx, right? And you want to find where fx equal to 0 occurs, right? So for that, first what you do, you find an interval for which you get the one value of fx as positive, right? So up this upper part here, so for at a1 my fx is positive, okay, it's positive side. For b1 part my fx value is negative. So by that logic, right, so if one value is positive at a1 and at b1 the value is negative, that means between a1 and b1 my function will cross the positive to negative part. So it will cut the x-axis, and it will achieve the value of 0 at some point in between a1 to b1, right? So you have to first find the interval. So it's very simple and effective method, okay? And it's also useful when you are dealing with the transcendental equations, right? So you find that first assumption is that fx is continuous function between interval a1 and b1, where uh, function value at a and b have opposite sign, right? So one value will be positive, another value will be negative. It could be reverse also, that fa1 is negative, fb1 is positive. So basically this condition will satisfy that fa into fb is less than 0, right? So that means there will be at least one root between this function, okay? Let's try to understand then how the step of this method works through simple example. So let's say I have function fx is equal to x to the power 4 minus x minus 10, and I want to solve its root by using the bisection method, right? So I will first guess some variable of x where I get one positive value and some variable and one variable where I get the negative value. So if I put the x value 1, I'm getting the f of 1 as minus 10, which is negative. If I put the value of 2, then I get the value of 4, which is positive. So I have two extremes ready, like this two extreme, okay? Now what we will do, we will find the next iteration point in between 1 and 2. So as it name refers, bisection method or interval halving, the next point will be the midpoint of this two extreme part. So 1 plus 2 by 2 is 1.5. Now you find the value of function fx1 at this 1.5 part, right? So this is also negative. So previously what we had was that root could exist between 1 and 2 because 1 was negative and 2 was positive. Now the idea comes that 1.5 is also the negative function value. So my root will shift. I mean, it will be between now 1.5 and 2, right? So now my root, the interval has reduced by half, and my now root will be between x1 and 2, right? So it's like looking at this way, that one value is positive, one is negative. I find the bisection point here. It is coming as negative. So that means my root will exist between a1 and b2, right? Previously interval was a1 and b1. Now it has reduced by half, and I get this new interval. I will again find the point in between, like say this is my f2 point, this is positive. So now my interval will become fa2 and b2, right? This way. So this way you half the interval every time and find where solution will lie. So after 1.5, your next iteration will be 1.5 plus 2 by 2, which is 1.75. Find the value of function. Based on its sign, you decide where root exists. So it will exist between x2 and 2. You do the next iteration. Now here at x3, your value becomes positive. So your root will be between x2 and x3. Same way, and you find and when you do multiple iterations, right? So after 8 iteration, I find the x8 value, and what you will find is that now your new interval or new value is not changing much from the two extremes, right? So in that case, you see the function value. So here it's 10 to the power minus 3. which is close to 0 for the practical consideration, right? It's close to 0 for practical consideration. So I will stop at x equal to 0, sorry, x equal to 8, and say that my solution is 1.8555, right? So here your stopping criteria could become that my function value is less or equal to the tolerance, right? The absolute value of function is less or equal to the tolerance, and that tolerance you can decide. So if my tolerance was 10 to the power minus 2, this satisfies the criteria and x8 becomes the solution. Let's say my tolerance criteria is 10 to the power minus 5. Then x equal to 8 won't satisfy the criteria, and then I have to do further iteration. Or you can do the tolerance criteria or stopping criteria as difference between the new value and the old value. If that values are not changing much, then also you can stop, right? So this is the basic idea. Now let's try to create our own MATLAB code which works on the bisection method, finds the root of the bisection method, and then we will compare our results with the inbuilt solvers that we have, right? So we have, since it's a single variable optimization problem, we will compare our result with the F0 part, okay? So let me just create a function file first. This is bisection method. Remove all the previous variables, clear the window, right? Now ask from user. First we will need some function, right? So ask from user, provide a function. So I will write input, provide a function through inline command. I'm specifically saying user to provide a function through inline command, right? I want that user provides me two extreme, provide a lower limit for search, then b is equal to input, provide a upper limit for search. You can ask for tolerance also. Provide the stopping criteria. So here what I'm asking from user is that first he provides me some sort of a function through the inline command. I'm asking them to provide the upper and lower limit. So basically I'm asking them this interval. So here value of 1 and 2 we had decided. Okay, so I'm asking that from the user, and the stopping criteria which I'm putting as a tolerance part, right? Now once user provides me two extremes, right? So our first thing in this part is to check whether the root exists between this interval or not. And how to do that? So here what we learned was, if I have two intervals a and b and my function value, so I find the function value at a and b and see if they have opposite sign or not. So basically I have to check whether the function value at a into function value of at b is less than 0 or not. If it's a negative, if it's negative, that means one of them will be positive and one of them will be negative. So root will exist in between. If not, then my interval is incorrect, right? So I will first put the condition if my function value at a into my function value at p is less than 0, then what I will print is print f the root exists between percentage f and comma a comma b. right? Else I will print same thing, that root does not exist between A and B. Dot slash does not exist between n. So first this condition check happens, right? Now let's say we found out the condition check, and we find that root exists between A and B. Now we have to find the exact solution, right? So for that exact solution, what will should be the my condition? So my stopping criteria is this part, that either function value is less than 0 or the successive variable value not less than 0, less than the tolerance value, or successive variable value difference is less than tolerance, right? So that is my stopping criteria. So it's a condition based stopping. So for that maybe I can use a while loop, right? Because while loop works on the specific condition. Till that condition satisfy, your while loop will run. Once that condition dissatisfies, it does not agree, while loop will stop. Okay, so we will do that. So I will say while function x is greater than my tolerance, I will run the loop. Okay, now here I have to define variable x first. Okay, so x is your a plus b by 2, correct? From interval halving. If that fx is greater than tolerance, that means I haven't reached my root. Okay, so I have to find the next iteration. Now in order to find the next iteration, what I have to check, that if f of a into f of x. Now I have to check whether the root lies between a and x, or x and b. So if f of a into f of x is less than 0, if it's negative, then my root lies between a and b. So my limit will change. A will remain a, my b will become x, the extreme boundary will become x. Else, if that this condition doesn't happen, that means root lies between x and b. So in that case, my a becomes x while b remains b. You don't have to put this line, I'm just putting it so that you understand it, right? And once you do that, you have updated a and b. Then you also find the new, you update a x also, which becomes a plus b by 2. Okay, once it has reached the end of the loop, it will check again the value of x, whether it's greater than the tolerance or not. If it's greater than the tolerance, then it will run the loop again. If it's not, then it will stop the criteria, right? So see, it's giving me suggestion that the assignment of b and a is unnecessary, which is fine, but this is for our understanding. Now what I also want is that once this condition ends, I want to find the solution also, right? So I will write f printf, the solution to given function is percent %f slash n comma x. Okay, this is my solution. So let's run this loop. I will put the value which we have seen here, x to the power 4 minus x minus 10. In line, x to the power 4 minus x minus 10, lower limit 1, upper limit 2, and 0.001. Uh, oh, sorry. It's a variable name issue. It should be f. Now if I run it again, 120.001. Right. So the root is existing between 1 and 2, and the solution. So see, right now it's giving me solution as 1.5. Okay, which is not something I need. Which we know that solution is exactly at 1.855, right? So that means we may have made some error, and what that error is, function at 1.5, while function is greater than tolerance. Oh, yeah, sorry. So this is a negative value, and our condition is that if function is value is greater than tolerance, but rather it should be the absolute value of the function is greater than tolerance, then run the loop, right? So that's why it did not run the loop, it just computed x equal to 1.5 and provided it as an answer. Now again, when I run it, I have in line 1, 2.001. Ah, why I'm making mistakes? Oh, sorry. It should show an error. See, variable naming and properly calling them is an important. So I made two mistakes. One was the syntax issue and one was the naming issue. That's why it threw in an error. See, now it has run the iteration and it's providing me the solution. And solution is at 1.85553. Okay, so it has gone to accuracy even higher than what we found through our own calculations, right? Now, here I'm just directly getting the solution. You can also print out the in between values also. So at the end, I can write f printf. Let's say I want to find each iteration and what's the value at each iteration. So let me create one variable I equal to 1. Okay. What I will do is I will print its value f printf my iteration, sorry, iteration tab the a value, okay, tab b value, tab x value, tab f of x value. Okay. So this is something I want to print. So this will be my first line. So let me put it outside the loop, or it can work here also. Yeah. Right. Then I write f printf percentage d slash tab percentage f slash tab percentage f slash t slash percentage f slash t. Okay, so iteration value is given by percent d, a value is given by percent f, b value is given by percent f, x value is given by percent f, and then again I will have percent f value. Okay, then I comma a comma b comma x comma func at x. Yeah. Now within the loop, I will update the value of I at all time. I is equal to I plus 1. Right? IABFX. And now again save this and run this part. So it should tabulate my data very nicely. 1, 2, and 0.01. Ah, I forgot to provide slash n. See, so I did not provide the slash n, so it was printing everything in one singular row, which is not a good thing, right? So let me provide slash n at the end, slash n. This will create a new line, space slash n, space slash n, And yeah. So can you see? It is showing me how with iteration the lower limit and upper limit a and b are changing. What is the new in between variable value, and what is the function value at that particular point, right? So this is how you can compute and calculate how your function is changing. So this is solution through bisection method, right? Now I know my function is this, so I can call f solve part, provide the func value, initial guess of let's say 3 and see. So fsolve is also converging and I'm getting the value as 1.8556. So it has provided my value with slightly less accuracy. Obviously, you can provide the tolerance with multiple commands provided here, but you can see R value and the MATLAB solver values are exactly matching, right? So this was about the bisection method. Then one more method that you have is the Newton-Raphson method. I'm sure that you might have read about the Newton-Raphson method somewhere in your 11th, 12th standard, right? So in Newton-Raphson method, it's a derivative based method, right, which is most commonly used to find the roots of your function or the real variable. So you start with some initial guess and then you go towards the root through this formula. So you have some initial value xi, and next iteration value which is closer to your fx is equal to 0 is given by xi plus 1 is equal to xi minus fx divided by f dex x. Okay, it converges faster because its rate is quadratic, right? So you get a faster solution in a lower iteration compared to the other methods, right? So if you look at the same example, I start with the initial guess of x0 equal to 2 and find the first iteration point. It will be x1 is equal to x0 minus fx0 divided by f dex x0, and you get the next point. Same way you do it, and you can see within the 3 iteration I have reached the value of 1.8556, which provides me fx equal to close to 0 value, right? While compared to that in the bisection method, you had to sorry in the bisection method you had to go to 8 iteration to reach the value of 1.855, while here within the 3 iteration I have reached the value of that. So Newton-Raphson is a faster method, it's a quadratic conversion, right? Obviously the disadvantage here is that it's computationally slightly expensive because here you are also finding the derivative of function. So for a simple function like this it will work, but for a for the complex equations you might not easily get its derivative, right? So in that case it might become expensive also. Again, the stopping criteria could be any of this. Either you can provide the stopping criteria on the function or its derivative or the successive x values. Okay, we will look at the example of Newton-Raphson method also through our own code, and then we will compare it with the MATLAB results that we get. And maybe after that we will stop, and I have some examples for you guys that you can try it out. So these are various problems. I think there are 10 or 11 problems. Yes. So you can try out this problem. So you have to find the root of this nonlinear equations with the help of whatever inbuilt MATLAB function that we have learned, and try to find it out. Try to find out its solution. Right? Apart from that, there are some quiz question also that if you want to take it, you can do that. Okay, so coming to the Newton-Raphson method, let's try to create our own code of Newton-Raphson method. Let me just see if I can. No, it should be very short. Okay. So like the previous case, what I will do is I will ask the function value, initial guess and tolerance. So I'm just copy pasting it faster. Just okay. So here one thing, since we want to use the, since we have to use the derivative of the function also. So what I will do is I will use the function definition through the symbols command, right? So I will write a some symbol since x, and I will provide, I will write input, provide a function through symbol x. Okay. Why this? Because as we learned in this part that if I have various ways to define an equation, right? So if I have a symbols, if I have defined the function through symbol, I can use the different diff command to find its derivative also, right? If I don't use that and if I do the inline function, so this becomes a numerical part. So in that case also you can find the differential, but then you have to rely on the numerical equation. So that will be a derivative at x, derivative at fx will be f of x plus h minus f of x minus h divided by 2h, right? So that comes from your Taylor series expansion. Okay. So we don't want to right now do that. We just want to use the symbols and differentiate function through MATLAB inbuilt command. Okay. So that's why I'm asking user to provide a function through symbol x, provide an initial guess value. Okay. And provide the stopping criteria. Okay. So first step will be, once you have this, I will run a while loop. Okay. And what was our condition? I'm putting the condition on the function only. Now, since I'm using the symbols, I will write substitute function x. Okay. If its value is greater than the tolerance, then for that part, run the code. Now here I will create variable x equal to x0. Okay, so that's how the loop will initiate. Okay, so it will substitute the value of x in the function, and if it's greater than tolerance, then the loop will run. I have to find the next iteration xn. Let me call it as xn is equal to x minus. What we have to do? We have to substitute f of x divided by f dash x. Okay, so that will be subs function at x divided by subs some function at x. So here I want to find the differential. Okay. So what I will do, diff of func, I will also define a differential of function as diff of func. Right. So this diff func becomes differential of that function. I'm substituting two values and finding the next iteration, right? So my x becomes xn. Okay, this is the end of loop. It will go back and check whether the absolute value of function at x is greater than tolerance. If it's that, then it will again find the solution. Also, we want to take out the like we did previously, we will use this to find how many iteration, in how many iteration we get the solution. So I will write f iteration. This should be outside. Value of x, value of function at x, then new line, right? Percentage t, value of f, value of fx. I, my value of x function, I is equal to I plus 1, I is equal to 1. Okay. So this is how we start, and let's see. So when I run it, I have been asked to provide the function which is x square minus x, sorry, uh, x square minus x minus 10. All right. Initial guess, let me provide the guess of 3, stopping criteria as 0.001. Uh, it shows some printing error. Percentage as is x value. Yeah. Oh, sorry. So here it should be subs function comma x, right? Sub functions comma x. Right? So now see, my value is different because it's providing me the value close to 3. So if I write subs function comma 3.70303, it's not coming that way. Why it's giving me an error? Just give me a minute. As printf substitute function x minus substitute differential x xn equals 1. Oh yeah, sorry. So here I forgot to mention one thing. So this is an absolute value. So here this equation is not well written, but if you will search for the uh, Newton-Raphson method, let me go to Wikipedia to check. So this is your equation that we are following. X of n plus 1 is equal to xn minus fx divided by f dex n. So why it's not showing me the correct results? I'm putting absolute here. Mm. Just give me a minute, I just have to figure it out. Yeah, this should work without an issue. X value substitute f function at x, substitute differential of function. We have provided func x square minus x minus 10. Oh, sorry, the function is incorrect, that's why. It is x to the power 4 minus x minus 10. I have written x square. That's one mistake. And even with that also, my answer, it's a fractional answer, right? So, sorry. Let me run it again. So this is x to the power 4 minus x minus 10. Initial gets that's 3, stopping criteria 0.001. Right? So now you can see it's giving me the correct answer. That function value at x equal to 1.855, I'm getting the value of 0. Right? Yeah, sorry, I thought I had put in the absolute, that's why it was giving me the correct answer, but it's not. Yes. So this is your correct way of finding the Newton-Raphson method. And same you can compare with the other method also. So if you will see, this is the basic funda of finding the solution to nonlinear equations. Obviously, we are looking, so this method that we have looked, Newton-Raphson and bisections, we have looked it for a single variable, so it's relatively easier. But when you have multivariable part, the method that you follow to find a solution becomes quite complex, right? But if you will search and see the documentation of this F0, Fsolve, VPA solve, you will find that at the heart of this solvers relies such equations, right? So in F0 description, you will find that they mention that it uses the combination of secant bisection or inverse quadratic interpolation. Similarly, Fsolve, it's a multivariable optimization, so it uses these two algorithms, right? So at the heart of this function, the numerical methods are same that you will use in your any optimization problem, but it helps you to directly get the solution. So in order to get the solution, like the way we find out the solution of this equation through the bisection method, we could directly just use the F0 command. But what we saw, we compared, okay, with the method that we are following is correct with the MATLAB functions that are available. So we can rely on these functions to you find the solution to this nonlinear programming, right? So that's how the MATLAB inbuilt solvers are useful. Now I want you guys to try out this practice problem where you have been given various nonlinear equations, okay, specifically transcendental equations. Then you find the solution to this equation through various solvers that has been given to you. Try to get the feel of this solver, how they work, how to define this function, and how to put them into this solver, right? Once you do that, from the next class onwards, what we will do, the next class we will solve the chemical engineering problem which involves the nonlinear equations in its model, and then we will rely on this uh, fsolve command to solve that multivariable equations, nonlinear equations, and find the solution. Okay, so that was it for today's class. Do let me know if you guys have any doubt. Okay, I will stop the recording. See you in the next class. Thank you.